Two of my favorite people, Derek Tracy and Robert Van Voorhees, will be putting the security into DevSecOps.
Hi, everybody. Thank you for joining us today. My name is Derek Tracy, and joined with me today is my esteemed colleague, Robert Van Voorhees. We are both engineers on the VMware's Tanzu public sector team. We're both Tanzu specialists with an affinity towards security and a focus on the Department of Defense. Today, we're here to talk to you about DevSecOps, kind of what it is, what it means, and how do we get started. With that, throughout this discussion, you're really going to see kind of three main themes, and all of these themes, they all kind of feed off of one another and help bolster each other along the way. And those themes are API-driven technologies, automation, and consistency. When you really think about it, you can't have anything that's automated unless there's an API or programmatic access to that thing. So that's where kind of the API-driven mentality comes about. Kind of all the tools and techniques and methodologies that we talk about today all have their hearts baked in API-driven workflows so that they can be automated. And we all know that the more automation that we employ, then the more consistency that we can derive throughout the system. And in this case, the system can be an application or kind of the system as a whole, everything from the hardware all the way up the stack. But before we really kind of dive in to this wonderful overloaded term, DevSecOps, I think it's really good that we start with a baseline. Let's start with the definition. Like, what is DevSecOps? At the heart, it's the practice of automating security at every phase in the SDLC, from start to finish. When you really think about this, what does that really mean? Well, if you look back into the roots of DevSecOps into DevOps, you can really start to tear that apart and get a glimpse as to what DevSecOps is and where does it fit in with the current DevOps methodologies that are currently in practice today. So let's do just that. When we really look at DevOps, we start with the code or the application source code. And then the application source code at the end of the day is often fed into an automated process. We'll call this a pipeline. Inside of that pipeline, we have a lot of tests that happen. Everything from unit tests, code quality scans, performance and integration testing, some smoke tests, all to make sure that the application source code, the application, is performing as it should be, that the edge cases are met and checked off, and everything is the way it should be. Collectively, we call this a continuous integration pipeline. One of the cool things about an automated process is we can now programmatically check to make sure that, hey, every one of these tests that we wanted to make sure that our code meets, all of these are met before we are able to exit this automated process. So in essence, we're able to enforce a level of rigor on the application code without introducing any humans in the loop here in this process. The CI process, or the CI pipeline, is fed into another automated process. And inside of here, we're dealing with things like creating services, because we all know that applications often don't operate entirely by themselves. They need backing services like databases, caching layers. You need to be able to provide some level of isolation and governance to that application to make sure everything is staying secure and is where it's supposed to be. Make sure your RBAC model is in place. Hook up some load balancing to the application to make sure it's fault tolerant and resilient. And then finally, we need to make sure that we hook up some hooks to do health monitoring and checking and have some observability baked into that application and where it's going to be sitting. Collectively, we call this a continuous delivery or continuous deployment pipeline. And again, just like the CI pipeline, we're able to ensure that, hey, every one of these checks, every one of these things are done up to a certain standard before we deem the application as being a successful running application. Now, we all know that this in today's current world, especially in the public sector, the speed of deployment and development of an application is hardly ever the limiting factor. Often the limiting factor comes down to the compliance, the security compliance and accreditation methodology. So let's take a look at that for a second. What does that typical security process look like for an application being deployed? Well, we usually start with a development team, and that development team, they are building their application. And if they're a good development team, they're also documenting their application along the way. They're creating an architecture. They're updating the ports and protocols. Everything tends to have a security spin on it, as I'm sure you've noticed. But they're documenting all of this as they're building their application out. And then after some time, when they're ready to deliver their application, they send that on to an external security team who performs scans on their software, does an initial check of their accreditation documentation, or that documentation describing their application that they've built up to this point. We'll call that a body of evidence. And then it's never right out of the gate. There's always, the changes that need to be made, things that need to be implemented, mitigations put in place. And the way that the security team communicates back with the development team is often by utilizing the scan results. Well, there's always a few iterations of this that goes on until finally they meet that first hurdle, and their code, the source code, their application dependencies, and their documentation is up to enough of a standard to move on to the next step in that accreditation process. And that often takes the form of a SCAR, essentially a security engineer that is going to take a deeper look at the application, make sure it's performing the way it's supposed to be performing, as well as the documentation going along with it and the scan results. And just like before, it's never right the first time. There's always a lot of back and forth, often taking the course of weeks, if not months, of back and forth throughout this process, just to get to the point where that security engineer is happy with the results and decides to make a recommendation to the next step in the next wheel in the cog, and that is the DAA, or the signing authority, the person that is going to kind of accept the risk, the potential risk that this application could bring to the rest of the enterprise. And ultimately, that signing authority is going to make a thumbs up or thumbs down decision. Can we proceed forward with fielding this application or not? Well, if you look at this and you look at kind of the last processes that we went through with the CI and CD process, I think you can draw some conclusions like, hey, let's try to gain some efficiency by turning this into an automated process. So how would we go about doing that? Well, first thing we can do is we can take the first step, which is that security scanning piece, and we can rip out the types of scans that they're doing, the dynamic and static code analysis, the dependency checking, making sure that none of the dependencies included in the application or their operating systems are on any hit lists anywhere. Maybe if we're advanced, we're doing some kind of fuzzing against the user inputs of the application, because you never know what the end users are going to throw at it. And collectively, once we do that, we're able to get rid of that first human in the loop. Just by taking and automating that process, we're able to take that human out of the loop. Since we've already demonstrated in the CI/CD automated pipelines that these checks are able to be gated, meaning like we have to pass all of these checks before we can proceed to the next step. Collectively, we call this a security pipeline. Now, if we take the next phase and we take that gating methodology and we apply it to the entire pipeline and say, hey, let's take all of the checks that the SCA, the SCAR, the security engineer, and that signing authority typically do to that documentation and to that source code and to the application operating environment. Let's take all of those checks and put them into this automated pipeline. And then at the end of this pipeline, let's give it the ability to say, give that thumbs up or thumbs down, like we want to proceed or not. Because keep in mind, as we progress through this, every step along the way, we're building additional documentation automatically and adding that to the body of evidence. Once we do that and we give that automated process the ability to give a thumbs up or thumbs down that this application is meets the requirements to go into production or to be deployed, we're able to eliminate 2 more humans out of the loop. Again, but what this really equates to is eliminating that weeks, if not months, of back and forth that go on between the development teams and the security teams. Since we've taken and we've codified all of the testing and the knowledge that, or the checks that each of these teams do, and put that into an automated process. So now let's look and see where the security pipeline would fit in with the CI/CD process. Well, right there you go. As you can see the flow, we're checking to make sure, hey, the continuous integration tests are all functional, everything's good to go. Let's move on to the security scans, and then step by step, we're mitigating risk every single step along the way until finally we have the application deployed into production. Well, if you really look at that, and you look at that CI tasks, and you look at those CD tasks, the CI tasks often look a lot like development tasks or development functions, and the CD tasks often look a lot like operations functions or functions that would be done by an operations team. So if you really look, like that's where kind of that name DevSecOps comes into play. So now we have a way to take and programmatically move an application and promote it from inception or ideation all the way into its initial deployment. Well, what if we took this same process and applied it not just to the application, but applied it to the entire operating environment that that application is going to be living in? What could that possibly gain us? Well, if you really dig in and you treat the infrastructure and the supporting functions of the infrastructure, the platform that's being built, if you treated it the same way you did the application and you deployed it utilizing, all of these steps along the way, you did your testing, your smoke tests, you did your security testing in flight along the way, what you would end up with is an environment a platform that is able to everything is automated. You're able to reconstitute it on the fly because no humans are in the loop to be able to deploy the thing out. You would have an API-driven infrastructure, which means that you'd be able to more easily deploy your applications in an automated way, and they would naturally feed into a DevSecOps model of deployment. You would gain greater consistency. The more humans you move out of the loop, the less change that you allow to be injected into the system as a whole. And that consistency would drive a more secure operating environment. And with that, you're able to really build up your secure supply chain, since you can now provably prove the pedigree and provenance of every single artifact and change along that makes up your entire platform along the way. But all in all, that's still not enough. What else is missing? Like, what else would an application need to function in order to be successful in this environment? Well, one of the first things that pop out is, how do we onboard services in a consistent, reliable manner that is sustainable over long periods of time as we bring on more and more services? These services can be databases, caching layers, message queues, the sky's the limit for the types of things that the applications need. It really depends on the application domain. We need to also be able to ensure your infrastructure portability. It's not enough anymore to be able to say, hey, I need to be able to deploy my application into like this on-prem data center. We have to be able to think about how do we scale out to support the cloud and hybrid cloud models? How do we deploy into each of these in a very consistent manner? How do we strengthen and double down on that secure supply chain? As we all know, especially the public sector, it's being looked at and hit with more and more of these supply chain type of attacks. And again, like when it comes to applications, observing the application running and everything around it is needed for a full picture for that day two security story. So how do you provide that consistent logging and auditing layer so that not every development team has to recreate the wheel when it comes down to logging? And to dive into each of these and more, I'm going to hand it off over to Robert to kind of take the deep dive down the platform route.
Right, thank you so much, Derek. So as Derek mentioned, we've learned about what DevSecOps is, this concept of creating compliance-driven pipelines to capture the actions that the individual security team and authorizing officials would be conducting in our environment. And we talked about how we can apply that to lay a foundation first into your hosting environment, whether that's on-premise or in the public cloud, to create the necessary hook points for your secure enclave to start accepting workloads. But to have your application teams go through that DevSecOps pipeline with all of the requirements, all of the STIGs and SRGs that you typically have to go through to get into production, that's asking a lot from those teams. It's putting a lot on them. So how can we create varying levels of abstraction that lie between those workloads that the application developers are creating to handle more of the inheritable controls and take things off their plate so that they can focus more on a narrow scope, while still applying that concept of DevSecOps and creating those automated pipelines within our environment. That's really where a platform starts to shine, not just from an accelerating application developer standpoint, but now that we've created these pipelines to also incorporate security, we're able to leverage the security aspects of it as well. So what we're putting in between really the green circle of workloads is that platform, and not just the platform itself, but an actual platform process, the process of creating a secure CI/CD pipeline to deploy that platform onto that consistent environment so that we can maintain that speed, as James mentioned earlier in the day, of getting in those patches well before they're in an exploitable position or any of the other things that developers don't really have the time to deal with alerts that there's a new problem with OpenSSL, or that this various CVE came out for Python, but they're writing an application in Java. A lot of that stuff slips through the cracks when you give too much responsibility out to those developers without helping them understand sort of the implications of taking on the entirety of a virtual machine, including all the runtimes and other capabilities on top of it. So by taking that CI/CD pipeline that Derek was talking about earlier with its dev and security and ops steps, and pulling out sort of that virtual machine and infrastructure levels that might lie below it, we're able to take a significant number of the security concerns that might be occurring for developers and instead impress them upon that platform and the actual pipeline to make sure that that platform is staying sort of consistent. And we see this not just in Kubernetes, but lots of other platform runtimes as well, is where you have sort of the configuration, and I'm using YAML here because that's the language of Kubernetes, but it would be a similar construct in other configuration-driven platforms. And then the actual containers that are part of the running services. And when I'm talking about the services here, I'm talking about all the individual components that make up a platform, because the platform itself is really just strung together services, providing things like load balancers, providing things like databases, providing things like routing to or do certificate management. And by taking those individual components and looking at them as their for their security impact, for any of the individualized CVEs that might be occurring in that service, and treating them as their own security pipeline, you're able to provide the necessary fine-grained visibility to each of the services. So as one of the ones I mentioned, a database is going to have a incredibly different sort of analysis that you want to look at. Is the persistable data being encrypted? Is the communication with the database always secure with password authentication as well as TLS? Are we doing the necessary auditing controls when a database is dropped or a column is dropped? That's going to be very different than what you're looking at for a load balancer, where a load balancer, you'd be looking more to make sure that traffic is only served up over 443, which is a requirement in the government, not even providing that TLS redirect. We just don't want port 80 open at all. It's only going to be the TLS traffic that you can access. And then making sure that that's using a modern form of encryption in its communication as well. So by individualizing those services and actually communicating with the security teams to find out what the requirements, because maybe in the intelligence community you have a different level of requirement than what you might see in the civilian sector, and actually asking those questions to the security team and saying, hey, we're actually going to create a database. What do I have to do to secure that database? And seeing those responses, you're able to now create a firm contract with your security folks to say, well, if I can show that the database is encrypted every time I create one, if I can show that the database is secured with a username and password every time I create one, then can I go forth and just start creating as many databases as I want? And by having that idea of here's where ports are defined in my service, here's where I'm making sure that I'm not a non-root user, here's where I have the necessary privileges, the source secrets, and agreeing upon what all of that looks like, you're able to set a much better way to communicate about what those services will look like when you come into the environment. So now we have that security environment where we are securely creating the virtual machines through that pipeline process, again, actually going through a separate security pipeline, probably one that application developers don't even see or know exists because it's abstracted away from them, and having those individualized pipelines that might get quite, there might be quite a lot of them that are going to provide supporting services, whether it be routing, logging, providing metrics to those applications, the database I mentioned, or messaging or caching that Derek had mentioned earlier. Now that we're going through those pipelines process to create all that stuff, we're able to point to security and say, hey, instead of this being sort of a we come to you for approval kind of relationship, you now have the ability, if you want, to go look at those pipelines anytime you want. So anytime you want to see the latest update of a database going out across my environment, just look and see at that pipeline. If everything's green, it means it's going through all the agreed upon processes we talked about in the past. So then you move up further and you start enabling the applications themselves, as Derek mentioned, going through that traditional CI/CD for apps and including that security pipeline process you had as well. But look at the tools that we're using, that scanning, that testing, that deployment process. Those themselves are typically supporting services. So whether you're running a static code analysis tool or you're running a small testing environment that might do fuzzing testing or user input testing, as Derek mentioned, all of that stuff is itself a supporting service. So what is the security process pipeline for deploying those services? How are they getting updated and maintained and deployed into your environment? And is the environment that they're running on, the virtual machines they're running on, also being maintained in compliance as well? So as you start enabling those applications and start creating that tooling to support your DevSecOps pipeline, make sure you're asking yourself, am I running those in a secure fashion where they can be maintained as well? Because very, very often the scanning applications that you're putting into your security process, those have very frequent updates. How do you, if you're in an air-gapped environment, how do you know that a new CVE is out if you haven't actually updated your CVE database on that scanning tool? How do you know that your fuzzing tests are actually going to work in your consistent environment if they're not similarly running in that environment? And then how are you deploying things out if you're trying to create small footprint environments to allow that to work at more edge-like locations?
Well, Robert, let's pause right there. Great session. We are at time. I want to thank Derek and Robert very much.